Alright, so here we wish to talk about the foot of a perpendicular. What do we mean by the foot of a perpendicular? To define what a foot of a perpendicular is, we need a line. Here we have the line ax plus by plus c equal to 0, and we choose a point P with the coordinates x sub p, y sub p. So that's a random point lying in the coordinate space somewhere, and you have a line somewhere else with the coordinates with the equation ax plus by plus c equal to 0. As you know, this is the most random and the most general form of equation that you can write for a line, and x sub p, y sub p are the most general way to represent a point in the Cartesian plane. Once we have that, we wish to draw a perpendicular from the line P towards the line ax plus by plus c, and we shall do that using a ruler. And let us draw a line like so. This is another line such that it meets the line ax plus by plus c equal to 0 at 90 degrees, and we call this line to be the perpendicular of the point P with respect to the line ax plus by plus c equal to 0. And the foot of the perpendicular is the point at which the perpendicular meets the line. Let us call that point by, say, F. All right. So what are the special properties of the point F? Well, the special properties of the point F, A, is that, well, if you extend a line, FP is perpendicular to the line ax plus by plus c equal to 0. That's the first important characteristic. And the second point that comes out from this geometry is the fact that F lies on the line. Well, the same line as before, so that's ax plus by plus c equal to 0. That's the only line we bothered really in this setup. Right, so using those points, we can actually work out the coordinates of the point F. And let us call the coordinates of the point F as x sub f, y sub f. And let us try to evaluate these coordinates given the point P and the line ax plus by plus c equals 0, right? So we wish to evaluate some sort of a relation of the point F to the point P in terms of the line ax plus by plus c equals 0. All right, so let's do that. So using these two characteristics I've mentioned before, we can write, well, the first thing we can write is that if I substitute this in the equation, then ax sub f plus by sub f plus c must be equal to 0 because it lies on the line. So this is the first equation of the special point f, the foot of the perpendicular. This is what we call the foot of the perpendicular. So this is the first thing, and what I've used here is the second point. Let me note it like so. So this is the second point I've used, and let us write a mathematical relation that takes into account the first point. Well, it says FP is perpendicular to the line ax plus by plus c. Therefore, if any two lines are perpendicular, then the slope of FP multiplied by the slope of the line should be equal to -1. This is what we know about perpendicular lines. And using that relation, what we can do is we can evaluate the slope of FP and relate it to the slope of the line. So slope of FP would be, well, if we know the coordinates of F, we know the coordinates of P, then the slope would be, well, xf. Oh, sorry. First, the numerator takes into account the y coordinates. So the slope is the difference in the y coordinates divided by the difference in the x coordinates. Y coordinates are, well, y sub f minus y sub p, divided by, in the same order, x sub f minus x sub p. That is the slope of fp. And we must multiply that with the slope of the line. Now, at this point, I can really work out, I know what the slope of the line is. It's the coefficient of x when the coefficient of y is 1. If this is the equation, well, let me write it here. If ax plus by plus c equal to 0 is our equation, then the coefficient of y here is b. So if we divide the entire equation by 1 by b, then the coefficients change like so. Plus y plus c by b must be 0, right? So I now wish to write this in the form of y equals ax plus c. Therefore, I make y the subject of the equation and shift everything the other side. Doing that yields minus a by b times x minus c by b. Therefore, the slope is the coefficient of x, and hence is minus a by b. So there I write it like as it is. And the product of the slope, of the two slopes rather, is -1, because of the property that they are perpendicular to each other. But that's a whole lot of information that we know just by the fact that f is the foot of the perpendicular of the line, of the point with respect to the line. Now what we can do is we can actually simplify this to write a general equation. We can cancel the negatives with the negatives and write it as so. Well, y sub f minus y sub p divided by b, and I multiply the entire equation by xf minus xp divided by a. When I do that, I cancel this out and I cancel this out from the left-hand side, and I introduce this factor on the right-hand side. And I leave what I've written here in yellow. I leave yf minus yp by b. And on the right-hand side, I get an x sub f minus x sub p by a. So we have this relation. So this is our first relation, the relation that we should have gotten by using this property. Right, so at this point, let me just tabulate my results. Well, at this point, I can get rid of the theory behind what I've done, and let me just leave what my results are. So this is one of my points. Let me just write it here. So these are the two bits of information that I wish to use. A times xf plus b times yf plus c equals 0, and this relation of yf minus yp by b and xf minus xp by a are the same ratios. So that's a very strong result right there. It's a very powerful result. What we can do is we can actually combine both of them to get a more interesting result. To do that, we must introduce something which I will try to explain in another video that involves the following. I'll just state it here. That's called componendo-dividendo. And it's a funny sounding statement which actually states that if you have two fractions, say p by q equals r by s, then the ratio is actually the same as p plus r by q plus s, and that's also the same as p minus r by q minus s. So what I'm doing here is I'm changing my numerator to the sum of the numerators in both the equivalent ratios or the difference. And I'm doing the same with the denominators. So that using this relation, we can modify the result number 1 as follows. So let me just write that relation in a special form. Let me multiply on the left-hand side the factor b by b, and do the same, but in terms of a by a on the right-hand side. Now, since I'm multiplying both the factors by 1, both the sides by 1, because b by b is 1 and a by a is 1, it really doesn't change anything about this expression. Therefore, we have, well, 1 becomes yf minus yp multiplied by b squared equals xf minus xp multiplied by a squared. Now treating, let me change my pen, treating this factor as p by q and this ratio as r by s, we can write that this whole thing, let me just shift it to one side, like so. Therefore, this factor right there should be equal to the sum of both the numerators divided by the sum of the denominators. And let me write that as follows. So the sum would be yf minus yp multiplied by b, this is the first numerator, added to x sub f minus x sub p multiplied by a, that's the second numerator, and whole divided by, well, b squared from here, and a squared from there. So this gives us a different way to represent the same ratios. This is the same equation we have in our first sentence, or the first statement that we have written. Now expanding this as follows, and multiplying b throughout and a throughout, we get, well, yf times b minus yp times b plus xf times a minus xp times a divided by a squared plus b squared, which is the same thing. What we have done is we just expanded that as follows. Now what we can do is, let me write it, it's getting a bit confusing at this point. Yeah, let's keep on moving. So now let's look at the second relation. Now what we choose to do is we choose to use this info and use it to modify the numerator. This info says, well, if you have a times xf plus b times yf plus c, then the sum should be 0. Do we have a times xf somewhere? Well, a times xf is right there. Do we have b plus yf? Well, we have b times yf, I'm sorry. And we also have them added to one another because you have a positive sign there and a positive sign there. So if you add both of them up, you must get, well, negative c, because if you take this c to the other side, you get this should be equal to negative c. So modifying that a little bit, we have, well, axf plus byf must be equal to negative c. Using that relation here, we can cancel these off and just substitute a negative c there. Now we have a different relation of xp times a plus yp times b plus c, whole with a negative sign, because I've taken into account this negative, and this negative, that changed the signs inside the bracket to positives, and I took care of the negative by writing it outside. Divided by a squared plus b squared is the same as the ratio. So let me write this once again clearly and properly to emphasize the importance of this expression. So let me just get rid of this as well, and the numbers there. All right. So now what we can write is, right, we have found out eventually that if xf and yf are the coordinates of the foot of the perpendicular drawn from P to the line ax plus by plus c equal to 0, then we have the following relation. Yf minus yp divided by b, which is this, and I'm ignoring the b by b, which is just 1, would be equal to xf minus xp by a, which is this, and I'm also ignoring the a by a because that's also 1, is also equal to this term right there. And hence, let me just get rid of this to write it as negative axp plus byp plus c divided by a squared plus b squared. Simple as that. This is the relation that gives you the values for y sub f and x sub f. So if you choose to evaluate the coordinates of the foot of the perpendicular for a given point P and a given line ax plus by plus c, remember that you already know this term of x sub p, you already know y sub p, you already know a, b, and c. So you know this, and this. The only variable here are the ones enclosed in white circles. Therefore, using this relation, we can actually find out the foot of the perpendicular. And that is why this relation is very important, and it helps us to evaluate what the foot of the perpendicular is. So I hope this video made sense.